So today we're going to talk about Kirchhoff's voltage law. Kirchhoff's voltage law states that around any complete path through an electric circuit, the sum of the increases in electric potential is equal to the sum of the decreases in electric potential. So when do we have an increase in electric potential? This is when we go through batteries or generators. And we have a decrease in electric potential when we go through resistors or other various loads. An example of a load would be a light bulb. So one statement to summarize Kirchhoff's voltage law is that voltage in is equal to voltage out, or voltage gain is equal to voltage lost. So jumping into our first example question. In this question, we know the voltage gain at the battery, but we're trying to find the voltage drop across the various resistors. So according to Kirchhoff's voltage law, we can consider individual paths. So when we consider this path, we know that we have a 12-volt gain. So we must also have a 12-volt loss because voltage in is equal to voltage out. So V1 is equal to 12 volts. Now considering V2, we can consider this path. Since we have a 12-volt gain, we also have to have a 12-volt loss. So V2 is also equal to 12 volts. And now trying to find V3. For this one, we can consider the bigger loop. We can consider this loop. We have a 12-volt gain at the battery, and we also lose 3 volts. So V3 must be equal to 12 volts minus 3 volts, which is equal to 9 volts. And it is important to note that across the parallel paths, the voltage drop across them is the same. The drop in V1 is equal to the drop in V2 is equal to the drop in 3V plus V3. So moving on. So what exactly is voltage? Voltage is electric potential energy per unit charge. So its unit is joules per coulomb, or V, volts. So now moving on to example number 2. In this question, we know the voltage drop across the various resistors, but we're trying to find the voltage gain in the battery. For this question, we can consider this loop. Since we know all the voltage drops, we can add them up to calculate the voltage gain. Because again, voltage in is equal to voltage out. So V is equal to 5V plus 2V plus 4V, which is equal to 11V. So now we're trying to find V1. There's 2 ways to find V1. According to what we learned from example number 1, we know that the voltage drop across the parallel paths are the same. So V1 must be equal to 2V plus 4V, which is equal to 6V. Another method to approach this is to look at this bigger loop right here. Since we found out that the voltage gain at the battery is 11 volts, then we know that 11 volts minus 5 volts minus V1 is equal to 0. So we can use the bigger loop to find V1 as well. Or we can just use what we learned previously from example 1 to make the voltage loss across the parallel paths equal.